would be nice if people were reinforced every time they hailed a cab, made a sales call, or hit a golf shot. However, in the real world, most responses are reinforced only some of the time. Psychologists have devoted an enormous amount of attention to how such schedules of reinforcement influence operant behavior. A schedule of reinforcement determines which occurrences of a specific response result in presentation of a reinforcer. The simplest schedule is continuous reinforcement. Continuous reinforcement occurs when every instance of a designated response is reinforced. In the laboratory, experimenters often use continuous reinforcement to shape and establish a new response before moving on to more realistic schedules involving intermittent reinforcement. Intermittent reinforcement, or partial reinforcement, occurs when a designated response is reinforced only some of the time. Which do you suppose leads to longer-lasting effects? Being reinforced every time you emit a response, or being reinforced only some of the time? Studies show that given an equal number of reinforcements, intermittent reinforcement makes a response more resistant to extinction than continuous reinforcement.
Intermittent reinforcement schedules come in many varieties. Ratio schedules require organisms to make a response a designated number of times in order to gain each reinforcer. Interval schedules require a time period to pass between the presentation of reinforcers. The four types of intermittent schedules that have attracted the most attention are fixed ratio schedules, variable ratio schedules, fixed interval schedules, and variable interval schedules. Click on each type of schedule to learn exactly what it entails. In a fixed ratio schedule, the reinforcer is given after a certain number of non-reinforced responses. In a variable ratio schedule, the reinforcer is given after a variable number of non-reinforced responses. The number of non-reinforced responses varies around a predetermined average. In a fixed interval schedule, the reinforcer is given for the first response that occurs after a fixed time interval has elapsed. In a variable interval schedule, the reinforcer is given for the first response after a variable time interval has elapsed. The interval length varies around a predetermined average. Let's look at some examples of intermittent reinforcement schedules. Click in the table on the left to choose the type of reinforcement schedule. Click on the icons on the right to choose either human or animal examples. A factory worker receives payment for every fourth piece finished. A rat receives a food pellet for every 10th lever press. On average, a pigeon is reinforced every 10th time it pecks a disc. The exact number of responses required for reinforcement varies from one time to the next. A slot machine in a casino pays off once every 6 tries on the average. The number of non-winning responses between payoffs varies greatly from one time to the next. On average, a pigeon is reinforced every 10th time it pecks a disc. The exact number of responses required for reinforcement varies from one time to the next. A rat is reinforced for the first lever press after a 2-minute interval has elapsed. Another 2 minutes must elapse before the rat can earn further reinforcement. An office worker's clock-watching behavior is reinforced by the arrival of break time every 2 hours. A surfer waiting for a big wave is rewarded approximately every 10 minutes, but the intervals between big waves vary considerably around this average. A pigeon is reinforced the first time it pecks a disc after a 1-minute interval has elapsed. The next intervals are 3 minutes, 2 minutes, 4 minutes, and so on, with an average length of 2 minutes. Let's check your understanding of the concepts just discussed.
Research has yielded an enormous volume of data on how schedules of reinforcement are related to patterns of responding. In general, ratio schedules tend to produce more rapid responding than interval schedules, because faster responding leads to reinforcement sooner when a ratio schedule is in effect. Note the steep slope indicative of fast responding for the fixed ratio and variable ratio curves. Variable schedules lead to greater resistance to extinction than similar fixed schedules. Variable schedules tend to generate more stable response rates than their fixed counterparts. Note the comparative smoothness of the response curves for the variable ratio and variable interval schedules. The response curve for the fixed interval schedule appears scalloped. When an organism has been on a fixed interval schedule for a while, a pause in responding usually occurs after each reinforcer is delivered. Responding then gradually increases to a rapid rate at the end of the interval. Repetition of this pattern yields the scalloped response curve shown. Most research on reinforcement schedules was conducted on rats and pigeons. However, evidence suggests that humans react in much the same way. For example, when animals are placed on ratio schedules, shifting to a higher ratio, that is, requiring more responses per reinforcement, tends to generate faster responding. People who run factories that pay on a piecework basis have seen much the same response in humans. Shifting to a higher ratio, requiring more pieces for the same pay, usually stimulates harder work and greater productivity, although workers often complain. Here's another parallel between human and animal reactions to reinforcement schedules. In rats and pigeons, variable ratio schedules yield steady responding and great resistance to extinction. Similar effects are routinely observed among people who gamble. Most gambling is reinforced according to variable ratio schedules. Such schedules tend to produce rapid, steady responding and great resistance to extinction. Exactly what casino operators want.
Let's review what you've learned. Continuous reinforcement occurs when every instance of a designated response is reinforced. Intermittent reinforcement occurs when a designated response is reinforced only some of the time. Intermittent reinforcement makes a response more resistant to extinction. In a fixed ratio schedule, the reinforcer is given after a fixed number of non-reinforced responses. In a variable ratio schedule, the reinforcer is given after a variable number of non-reinforced responses. In a fixed interval schedule, the reinforcer is given for the first response that occurs after a fixed amount of time. In a variable interval schedule, the reinforcer is given for the first response after a variable time interval has elapsed. Research has yielded an enormous volume of data on how schedules of reinforcement are related to patterns of responding. For example, fixed interval schedules tend to yield a scalloped response curve. Ratio schedules tend to produce more rapid responding than interval schedules. Variable schedules generate steadier response rates and greater resistance to extinction than fixed schedules.